Okay, so this is our first in a series of videos that we're going to incorporate into our statistical academy on one of the most important tools in statistical analysis, the standard deviation. And it's the bedrock. It's one of the bedrocks of statistical analysis. So it's all part of the central limit theorem. We'll be talking more about the standard normal distribution. But what we want to understand about standard deviation and why it's so important is it gives us a sense if we have enough data that's good data, not just what the average of the data is or the average of our numbers, but also how those numbers vary from the average, which allows us to, through the genius of the standard normal distribution, allows us to standardize the numbers like percentages and then understand on a probability basis how much what numbers we can expect that deviate from this average. I know it sounds a little confusing now, but it'll seem more clear as you watch the videos. So as an example, I'm a sports fan, and these are two ball players, right? These are basketball players. So these are their last 10 games, right? This is the scores that they have for the last 10 games. And let me stop here and say that more important than anything you do in statistics is to understand your data. Make sure your data has integrity, that it's good data, because garbage in is garbage out. And that ultimately you could feel confident and you know what you're doing with your data. So if you have to have some common sense, I mean, plenty of people are mathematicians, but at the end of the day, they really just running the numbers. To be really good at this, you want to not just run the numbers, but understand what numbers you're running and why you're running those numbers. So in this case, we look at these two players, and when we total up these scores of the last 10 games, we get the same total, 100. Okay, that's great. And the average for both of them are the same. And basically, just as an aside, as a little Excel tutorial, and Excel is a great tool. I mean, there are much more sophisticated tools that if you're going to continue to study statistics, you're going to want to learn, like SPSS or Stata or R, that allows you to do a lot of stuff. Like it's like using earth moving equipment as opposed to Excel, which is more like a big like SUV, a big pickup truck. Excel's great, but there are tools out there that are like earth movers. And as you get more steeped in this stuff, if you really want to do it, you want to learn the different statistical methods. And I'll probably do some videos as we move along down the road using those programs. But here we know the average is 10. And how I found that was just by going up to formulas and clicking on formulas, and everything is under more functions. You will get that under statistics, and it's all there. I don't want to click too much because I don't want to lose the recording, but a lot of this stuff is ready-made for you. So if I just plug that in, I'm going to get a 10 on the average. So if I know nothing more about these two players, I think they're the same. Maybe they both average the same number of points a game. And then the other statistical tools, what we call location, helps us to understand this average, and that would be the mode and the median. So the mode is the number that occurs most frequently in the data set, and just by eyeballing it, you can see it's the number 10. But if you take a look at it, I just asked for mode, which again you could find under statistics. And then here you'll see that just eyeballing it again, 5 is the most frequent number. So that's the mode, and the median is the number that occurs toward the middle. So you can kind of plug that into by using the function median. And like again, most tools, if I used descriptive statistics in Excel by downloading the data, which is a conversation for another day, you'd get those statistics. But one of the properties of the central limit theorem and the standard normal distribution is these numbers should always be the same once I standardize these numbers. Or once I standardize my data, then the mode, median, and average should always be the same. And even though to the untrained eye, we would assume that the average is the same and the players perform equally, we would understand through the magic of standard deviation that that's not the case, that there are variances from the average that have to be accounted for within the data. And no matter what the data is, in this case it's basketball points, it could be miles per hour. It could be a test of a pharmaceutical product. It could be anything. You are going to get the ability to plug these things into into standard deviation to find the normal distribution. And once we feel confident with that in our data, then we could measure the probabilities of how far a specific data point will be from the average. And depending on how the data is dispersed or varies from the average, we will have different probabilities, which we'll see as we move through these lectures. But you first have to start with finding good data, finding the average or the mean, and mean and average are the same thing, and then and that's called location. And once I have those numbers, I can start to begin to work on standard deviation. So that's the first in a series. We will be doing more of these.